So the other day we were talking about roller coasters going down hills and increasing velocity and all that stuff. And we said we could ignore air resistance, right? And some of you were kind of saying that's not a real life situation, but what we learned there can be extended to include systems where you can't ignore friction, right? Or where other forces act, okay? So we've been talking about closed systems, right? In a closed system, all the energy you have to start equals the energy you end with, right? Energy is conserved. All the energy you start with equals all the energy you end with, right? It's a closed system. There's no outside forces acting. So if this were a closed system, there wouldn't be any friction here. The only force acting on this block as it slides down would be gravity. And gravity is what's doing the work to change the potential into kinetic. Right? Does that make sense?
Yeah.
Now, if I have this frictionless section of track, and I have this friction over here, will this frictioning portion, will this do work on the block?
No.
Negative work.
Yeah, it'll do negative work, right? Because when the block gets to here,
Yeah, go ahead. Yeah.
when the block gets to there, it has a velocity going which way?
Negative or slower. I don't know.
Okay. Velocity is going that way, right?
Yeah.
So which way is the displacement?
Opposite.
Displacement's the same way,
Same.
right? Which way is the force of friction act?
The opposite way.
The opposite way. So this friction will be doing negative work on the block, right? Does that make sense? Does that make sense?
Yeah.
So friction is an outside force that wasn't there, right? But now it's doing work. So it's no longer a closed system. It's now an open system. Okay? Open system means outside forces on the system. Okay? Those outside forces can be any number of things. Okay? The biggest one that we'll come across is friction. Okay? Could also think about it this way. What if I had a bottle rocket attached to the back of the block, right? And when it got here, the bottle rocket ignited and propelled the block, right? That would be an outside force, right? Now, kind of giving that a real world situation, think about if you're riding a bike, right? If I'm riding a bike and I'm at the top of a hill, okay? If I just coast down the hill, okay? That's a closed system. All my potential turns into kinetic, right? Right? If I start going down the hill and then I start to pedal, right? I'm doing work on myself on the bike, aren't I? Is the system still closed? No, it's open now. Because I'm doing some work that does what to my energy? Increases my energy, right? So pedaling your bike as you go down a hill, that's doing work to increase your energy. Your force and displacement in the same direction. This friction is doing work that decreases energy. Okay? Does that make sense, guys?
Yes.
Yeah.
Okay. So this example is what I'm going to use to teach you about open systems. And then the worksheet I gave you lets you determine if a system's open or closed, and then do some practice. All right. So let's try this out. The block's up here. What type of energy does it have?
Potential.
Potential, because it just has a height, right? Is there any kinetic? No. It starts at rest, and then a very small, minute force, almost unnoticeable, touch the block, and it slides down. Right? It's kind of a lot like sledding, isn't it? Right? You come to the top of the hill, you put your sled down, you sit in your sled, you lift your feet up, you start going. Right?
Not always.
Well, depends on where you start, right? When you get to the bottom of the hill, the sled eventually comes to rest. It comes to a stop because the snow's putting friction on your sled, right?
Yes.
Or it comes to a stop when you hit the fence. The fence does a lot of work in a short period of time, right? Okay, sometimes gives you a headache too, right? Right? So, in order to stop the sled when you're sledding, some other force has to do negative work on you to take your energy away. Right? To slow you down and stop you. Does that make sense? Right? So it's kind of the same situation. block sliding down. It gets to the spot where the hill is really icy, so there's no friction. And now the snow isn't as icy, so now there's more friction. It slows you down. Right? Basically, it's sledding, but just put into a block sliding down an incline. Right? So that helps out. All right. So if this were a closed system, what do you guys know about energy? Conserved, right? So we know that the mechanical energy initial equals the mechanical energy final, right? Right?
Yeah.
Now, if this is a person riding their bike, and they start pedaling as they go down the hill, right? What would that do to their energy available at the end? It'd be more, right?
Yeah.
If this was a person riding a bike, okay, and there was a big breeze as they're going downhill, slowing them down, right? What would that do to their energy available at the end? It decreased it, right? Either the wind or the person riding the bike. In order to change the energy, they have to do what?
Work.
They have to do work. Okay? Because remember, work is the change in energy, not velocity. Work is the change in energy. Alright? So, if we have an open system, we have to add a term to this equation called WEXT. What does EXT stand for? External. Okay? So, WEXT is work external. Okay? And what that means is it's work done by an outside force. Yep.
It's just underlying.
Yeah, just work external.
Okay, so you have work done by an outside force.
Oh, thank you.
Nice job, Rex. Way to catch that.
I did EXTER. Oh yeah, I did. ERNAL. Thank you.
Okay.
Got excited.
It's in a row.
Just having an
So-
awesome day.
It's work done by an outside force. All right. So when you're pedaling your bike, you're the external force.
Sure is.
You're doing work to increase your energy, right? Adds to your initial energy, makes more available at the end. Does that make sense?
Sure is.
If it's the wind blowing, the wind does negative work, which means this W would be negative because the force and displacement move in opposite directions. Right? When wind blows, it slows you down, right?
Yeah.
So then you have less available at the end.
Sure.
All right? So your work external is always added to your initial energy because that's what's available at the end. Does that make sense, guys? Does that make sense?
Yes.
Okay. So the question here is, how far does the block slide? How far does the block slide before coming to rest?
To be.
How can we figure this out? We can do some algebra, right? Mechanical energy initial. That is PE initial plus KE initial, right? That K is terrible. Okay. Right? Work external. That will be force times displacement. Right? ME final. PE final plus KE final. Right? Does that make sense?
Yeah.
Yeah. Now, in this problem, we have initial potential energy?
Yeah.
Yes. We have initial kinetic energy?
No.
No. There is a force that's friction. We want to find the displacement. Do we have final potential energy? No. Do we have final kinetic energy?
Yeah.
Before the block comes to rest. So that means velocity is 0. Do we have final kinetic energy? No.
Yes.
Okay. So that means our initial potential plus our work done equals 0. Alright? So, potential energy is mgh.
Mm-hmm.
So, I'll plug it in like this. So, mgh plus F times D equals 0. Does that make sense? Okay. So now let's plug things in. M is 2. G is 9.8. H is 3. Force is 5. Times the displacement equals 0.
Yep.
Now there's one thing I forgot.
The D-force.
Does anybody know what it is?
Negative.
Negative where?
9.8.
On 5.
On the 5.
Bing.
Why does this 5 have to be negative?
It's in the opposite direction.
Good, negative work. Force and displacement in opposite directions, right?
Yeah.
So negative work. Okay? Does that make sense? Here's some calculators going 2 times 9.8 times 3. What is that?
58.8.
58.8. So we have 58.8 minus 5d equals 0, right? So now we need to solve. What do you want to move, the 5 or the 58?
5.
5? Okay. We'll move the 5. Loudest person wins, right, Rex? Okay. So then I'm going to write it over here. 58.8 equals 5d. What do we do now?
Divide.
By
5.
5. So how far is the block slide?
11.7.
11.6.
Does that make sense?
Yeah.
Yeah. So you guys see how external work can play a role? Yeah. All right. Are there any questions?
Ooh, no.
Any questions?
Did you